Hey guys, welcome to the next video, even the next chapter, chapter 14. Let's just get this to work there, chapter 14. And notice here it says kinetics of a particle, work and energy. So we're continuing with kinetics of a particle. Remember kinetics? Kinetics, we are looking at what causes motion, what causes the motion, and kinematics is the motion, meaning we're looking at acceleration, velocity, displacement, etc. So that's the motion, acceleration, velocity, displacement, position. And then kinetics, we're looking at what causes the motion. In chapter 13, we looked at force and acceleration. So if we had force and acceleration information, we would use the techniques from chapter 13. Now, what I want you to see is that as an introduction here, a quick overview, chapter 14 is dealing with something called work and energy. We're still dealing with what is causing the motion, okay? But we're going to look at a different way of solving these problems using work and energy. And I'm just going to write this equation out here. Actually, I've got it down here. Here it is. Take a look at these two equations. It's the same equation. This governs chapter 14. This equation, it's the same equation, just written differently. What we have here is we've got the sum of u1 to 2. This term here and this term, right, it's the same term, is the sum of all the work done by forces. Okay? So we know that work is only done by a force when a particle moves in the direction of the force, but we'll get to that in a minute. Don't worry about that. But I want you just to take note of this equation. This is the work done by all the force, and inside of this equation, we'll see this in a few videos time, or the next one, we have force and we've got displacement information inside the work. Remember that work is, look at this, there we go. I'll get into this in more detail in the next video, but work is force times a displacement, just as a general idea. So inside this term, the sum of all the work done is the sum of all the work done by all the forces. Okay? Then look at these two terms. Here we've got a half mv2 squared minus half mv1 squared. You can also obviously write this out as half mv1 squared plus the sum of all the work done from 1 to 2 is equal to half mv2 squared. That's just rearranging this. And then this T1 is this term. This is the kinetic energy. T1 plus the work done is T2. So the kinetic energy of this particle at time 1 is equal to, plus all the work done on that particle is equal to the kinetic energy at time 2. Okay? So take note of this. Here in these two, so in this one we've got force and displacement information. We'll see that in a minute. Then in these two we've got velocity information. Okay? So to come back here, you need to see this. In chapter 13, if we had information regarding force and acceleration, we could solve using techniques in chapter 13. However, in chapter 14, if we've got force information, velocity information, and displacement information, we can use the techniques in this chapter, which is called the principle of work and energy. Principle of work and energy. Okay? You can see there's work, there's the work, and there's the energy. Principle of work and energy allows us to solve problems that involve force, velocity, displacement. Okay? Whereas in chapter 13, the force and acceleration obviously allows us to solve these problems that involve force and acceleration. But then if we wanted to calculate velocity, we would need to integrate the acceleration, if you recall, to find force and velocity in these problems. Okay? Is there anything else that I would like to say here? Oh, okay, so this is the big picture. We want to work with this equation, the principle of work and energy. But before we can get to this equation, which is in 14.3, if I'm not mistaken, 14.2, my apologies, we must focus on this second term, work. So the next couple of videos, we will focus on what is work, what are the different types of work, and how to calculate them. Okay? See you in the next one.